Hi all, welcome to my first virtual class. I'm Madam Kong. The purpose of this video is to discuss the first chapter in SK025 Chemistry, Reaction Rate, by using the latest 4 sets partial question. Before we start, I would like to do some analysis for the physical chemistry in SK025. There are 3 chapters for the physical chemistry part. First chapter is reaction rate, second chapter is thermochemistry, and the third chapter is electrochemistry. For the paper 1, total is 40 marks. So roughly around 25% from physical chemistry. And then the paper 2, full mark is 100%. So total around 38% for paper 2. You can check the marks allocation for each topic from the table. Now let's start on our discussion for the first question. PSPM set 2015-2016. Okay, this is the original question. This slide I already underlined and highlighted some important points. So let's go through it together. The decomposition of hydrogen peroxide is according to the following equation. So the equation is given. The rate constant for the decomposition of 2.32 mol per dm cube peroxide is 7.3 times 10 to the power of negative 4 per second. Okay, there's no question from here, but there's important information you need to know. Rate constant is given, and then the unit is per second. You should know when the unit is per second equal to per time. So per time, reflect this is first order reaction. Okay, next, plot a graph based on the data in the table. So you need to plot a graph. For this question, there is no specific, whether one a linear graph or half-life graph. So you can choose either one. Okay, from the plot, determine the order and half-life of the reaction. So for the second sentences, right, okay, there are 3 questions. First, you need to plot a graph. Based on the graph, you need to determine the order of the reaction. So the first order, second order, or third order. This one you know already, just like I told you, all right. And then the third question, half-life. If you know the order of the reaction, should be no problem for you all to find out the half-life. Okay, next. Calculate the concentration of peroxide at 1600 seconds and calculate the percentage of peroxide decomposed up to 1600 seconds. Okay. From here, right, you should know you have to apply integrated rate law. Okay, next, part B. Both reaction rate and rate constant are temperature dependent. Briefly explain the effect of temperature on reaction rate by using Maxwell-Boltzmann distribution curve. So everyone should know, right, what is Maxwell-Boltzmann distribution curve, and you have to know how to draw it. Since the question wants you to explain, you can explain according to the drawing. Let's discuss about half-life graph. For half-life graph, right, we just need to prepare one set of data. So we just follow the data given by the question. Plot a graph concentration of the compound versus time. Then we check what kind of graph we get. For zero order, we will get a straight line graph which with negative gradient. And the time consumed for each half-life will reduce to half. Then if for first order, we will get a negative slope curve graph. And then the time consumed for each half-life is constant. So check, the first half-life, the time consumed is 20 seconds. Next, second half-life, the time consumed is 40. So the difference between the time is 20, 20. So the half-life is constant. Time is equal to x, sorry. Okay, and then for the second half-life, we also will get a negative curve graph. But the time consumed for the first half-life is x, and the second half-life is double up. Initially is 10 seconds. 10 times 2 equal to 20. 20 plus 10 equal to 30. So the time consumed for each half-life is double up. So you can check the pattern and the time consumed for each half-life to determine the order of the reaction based on half-life graph. Let's discuss for linear graph. If for linear graph, we need to prepare 3 sets of data if we're not sure the order of the reaction. So the first one is concentration versus time. And then the second is ln concentration versus time. And the third one is 1 over concentration versus time. Then we check. For concentration versus time, if we get a negative slope linear graph, this indicates this is zero order reaction. If we're plotting the ln concentration versus time and get the negative linear slope graph, then this indicates this is first order reaction. If we plot the graph 1 over concentration versus time and then get a positive slope linear graph, then this indicates this is second order reaction. But based on this question, we already know this is first order reaction. Why? Because the unit of the rate constant is given, which is per second. So we can ignore this and ignore this. We just focus to draw one graph, which is ln concentration versus time, and check whether you can get the negative linear graph or not. This summary table is shown in my IG and FB. You can check it. It will help you to answer the question that related with zero order, first order, and second order. Normally, the question will ask about, write a rate law or rate equation. So always must remember, you must write down rate equal to, then only write out the equation. K is the rate constant, here is the concentration of the compound, and then zero order. Here the concentration with first order. Here is the concentration with respect to 2 is second order. Next, you must remember the unit of the rate constant means the units of K. Zero order is molar per time. First order is per time. And second order is per molar per time. These two is related the concentration versus rate. And then another important is for part is integrated rate equation. Because the question always asks you to find out the K value or T, the time, or the initial concentration, or the percentage of decomposition, or the percentage of remaining for certain compound. So you must remember the integrated rate law equation for different order. Next is about the linear graph, so that we explained before. Next is the formula for the half-life. Different order of the reaction have different formula. And then this one is the graph of concentration versus time that also we discussed before. Now let's discuss the answer for this question. So first, you need to put a graph. The first point to when you need to draw a graph is make sure you write down the title. So the graph of long concentration for hydrogen peroxide against time is the title. Second point, make sure you label the y-axis. For this case, the y-axis is long concentration hydrogen peroxide. Then you need to write down the x-axis, which is time with unit second. Third point, you need to ensure that you use suitable scale. For this case, the y-axis is 0.5 and the x-axis is 500. Fourth point, you need to assign the dot. The dot is based on the data, long concentration hydrogen peroxide. Fifth point, you need to connect all the dots. So then you complete a graph. Okay, based on the graph, right, we obtain a straight line linear graph with a negative slope. This proven the decomposition of hydrogen peroxide is first order. So you must write down this statement in order to explain the question. Determine the order of the reaction based on graph. At the same time, you can write down over here, unit of rate constant is per second. So give you the hints, this is first order reaction. Then the next question asks about the half-life. So based on formula, the half-life for first order reaction is ln 2 over K. The K value we can get through the graph. First, you need to find out 2 points and label x1, y1. Label x2, y2. Okay. Based on these 2 points, you find out the gradient. y2 minus y1 over x2 minus x1. Then you will get the value. So this value is the K value with unit per second, because this is strict constant, the unit per second. Then substitute the K value into the formula and you will get the answer 949.52 seconds. Always remember, the final answer must with unit. Without unit, the final answer is wrong. Next, okay, we need to find out the concentration at 1600 seconds. So before we write down the general formula, we must do an assumption. Let concentration A equal to the concentration of hydrogen peroxide. Then you substitute all the information given. Initial concentration is 2.32, and then the K value that you get from previous question, and the time is 1600 seconds. Okay, then you will get the answer 0.721 mole per TM cube or molar. Next, the question asks about the concentration of hydrogen decomposed in percentage. So you must find out the concentration of decomposed by using the initial concentration minus the concentration at 1600 seconds. So 1.599 molar is the concentration of hydrogen hydroxide decomposed at 1600 seconds. Then the question 1%. So you're using the concentration decomposed over the initial concentration times 100%. Then you will get the final answer, which is 68. Now we start to to explain briefly the effect of temperature on a reaction rate by using Maxwell-Boltzmann distribution curve. So first of all, we must know how to draw a Maxwell-Boltzmann distribution curve. The first thing, we need to label the y-axis, which is fraction of molecule having a certain kinetic energy. Then we need to label the x-axis, okay, which is kinetic energy. After label both axes, then we need to draw two curves. Okay. Curve 1 with higher peak, with lower temperature. Second curve, it is with red color and have lower peak, labeled as T2. So we need to mention that the temperature of T2 is greater than T1. Then we need to assign a line to indicate this is a line with energy higher than or equal to activation energy. Then we have to label two different portions to indicate the number of molecules with energy higher than or equal to activation energy. So everybody look at the blue area. The blue area is the number of molecules with energy higher than or equal activation energy at T1 with a higher peak. And then the whole area, the shaded area, is T2, where the number of molecules with energy higher than or equal activation energy. Once you finish label everything, then you start to explain. So for the first point, you must answer regarding the shaded area. Okay, normally we compare the T2 to T1, what happened. So the shaded area is the number of molecules with energy greater than or equal to activation energy. So this happened at higher temperature, T2. So the average kinetic energy increase. Then fraction of molecules that have energy greater than or equal to activation energy increase. So the main point of here is average kinetic energy increase. After that, we need to explain about the frequency of collision increase at higher temperature, T2. So it will make the effective collision, okay, the frequency of effective collision at T2 is higher than T1. So this will make the rate of reaction of T2 is higher than T1, which lower temperature. So I repeat again, the four main points. The first one is talking about the average kinetic energy. Then what happened to the frequency of collision? Next, what is the frequency of effective collision? And the last point is the rate of reaction increase. Now we proceed for PSPM2 set 2016 and 2017. Again, this is the original question paper. So if you check the original question paper, there are two versions. One is in English. Below the English is the Malay version. If you not really understand for the English version, you can try to read the Malay version. Okay, let's look at second question. Reactant S react to form product C and V at constant temperature according to the following reaction. In an experiment, the data obtained were shown in table 1. So I special highlight over here because we need to know the initial concentration of the reaction. So when time equal to 0, the initial concentration is 4.5 molar. Okay. Next, the question wants us to using integrated law method. Integrated law method actually is linear graph. Plot a graph to prove that the above reaction follows second order. So for this part, very clear. What we need to plot is second order linear graph. Means the graph is 1 over concentration of compound versus time. Next, calculate the value of the rate constant, half-life, and write the rate law for this reaction. So these sentences, there are 3 questions. We need to find the rate constant. Then we need to find out the half-life. And then we need to write the rate law. Based on your graph. Okay, this is very important. Based on your graph. Based on your graph. So you cannot use calculation method. You need to base on your graph. Determine the concentration of S at 1500 seconds. Previous question also need to determine the concentration, but we are using calculation method. But this question insists based on your graph. Okay. Next, the second part of the question is in a reaction, the initial rate is 2.25 times 10 to the power of -3 molar per time. When the concentration of W is 0.33 molar, the reaction is first order. Now the question wants us to calculate the initial rate of the reaction when the concentration of W is 0.85 molar. So maybe some of you might confuse. I have to apply which formula? Actually, this is initial rate method. Last time this kind of question, normally a table will be given, the initial rate will be given, the concentration of the compound will be given, and then you can compare and cancel off each other, and then you get the first order with respect to Y, second order with respect to X, something like that. But this question in sentences, not in table. Okay, the third part of the question, given the rate constant for the first order is 25 degrees Celsius and 35 degrees Celsius. So, and then the rate constant given, 25 is 1.74 times 10 to the power -5 per second. And then the 35 degrees Celsius is 6.61 times 10 to the power -5 per second, respectively. Determine the activation energy. So, activation energy means we are going to apply Arrhenius equation to find out the activation energy. Always remember, when we apply the Arrhenius equation, we must convert temperature from degrees Celsius to Kelvin. Other than temperature, discuss 2 factors. The question discuss. So we need to discuss in detail the factors that affect the rate of reaction. Okay, next we are going to analyze the question number 1. Plot a graph. How to plot it? So first of all, right, we must convert all the concentration S to 1 over concentration S, because this is second order reaction. So we need to plot a 1 over concentration S versus time graph. After we calculate the value of 1 over S, then we follow the 5 steps as we discussed before. Again, we need to make sure we write down the title for the graph. Concentration of graph 1 over concentration S against time. Next is about the y-axis, 1 over concentration S. Make sure you write down the unit per mole pm cube over molar. Okay, next is the x-axis, time in minute. Third point, make sure the scale used properly, 0 to 10. So for the x-axis is 10, 10, 10, and then for the y-axis is 0.1. Then the fourth point is assign the thought. Okay. Last, you need to connect all the dots. So based on the graph, 1 over concentration S against time plotted, and the graph is a straight line, linear graph with positive slope. So proven, the reaction of S is second order reaction. Okay, then we continue for question 5 first, because the question 5 needs based on graph. So determine the concentration of S at 1500 seconds. Okay, maybe some of you curious, my graph is in minute. Now the question asking in second. So what should you do? Actually, it's simple. You just convert the second into minute. So 1500 divided by 60. So the answer is 25 minutes. So for 25 minutes, okay, you try find out the concentration. Okay, for 1 over concentration, the answer is 0.47. So on the graph, at 1500 seconds, 1 over concentration S is equal to 0.47. So just apply the simple mathematics, find out the concentration of S, which is 2.13 molar. Okay, you need to find the gradient. So as previous question, you need to find 2 points, and then you find out the gradient by using the 2 point y2 minus y1 over x2 minus x1, and then you get 0.01. Because it's second order, so you must make sure that the unit is correct, per molar per minute. Okay, then apply the K to this formula in order to find out the half-life for second order. So you notice, right? Okay, here is the initial concentration. That's why just now I explained. At the initial, the 0 minutes, the initial concentration is 4.5 molar. Then you successfy the half-life for the second order, which is 22.22 minutes. Okay, so next question asks you to write down the rate law. So rate equal to, again, when the question asks you to write down the rate law, must write down rate equal to rate constant. Okay, the concentration of S to the power of 2, because this is second order. Okay, question the sixth. Okay, the sixth question. So you have to write down the rate law again. And then you have to compare the experiment 2 and experiment 1. Experiment 2, the rate 2, kW. In experiment 1, the rate 1, kW, the initial concentration. Substitute everything. K cancel. Now we can find out the rate 2. So, is it simple by using initial rate method? But the pattern is a bit different with what you have practiced before. Okay, now the question 7 is related with Arrhenius equation by using calculator method. So first write down the general formula and then substitute everything. So EA over R, the R value is 8.314 joule per mole per Kelvin. And then 1 over the temperature, make sure the temperature must be in Kelvin, plus 273.15 or plus 273 also acceptable. So the final answer is 101,950.69 joule per mole. It depends on you. If you want to convert to kilojoule, yes, no problem. If you don't want to remain this answer like this, also acceptable, unless the question insists kilojoule per mole, then you will have to divide by 1000. Okay, the last part of the question, okay, you have to state 2 factors, okay, not state, explain, discuss, so you have to write more. So first, if we look at size of solid reactant, so you must mention smaller the size of solid reactant, larger the surface area exposed for reaction. So next, talking about frequency of collision, next effective of collision, the last is the rate of reaction. Same for pressure, only the first part is different. So the first part you mentioned when pressure applied increase, okay, the number of reacting particle per volume increase. So what happened to the frequency, what happened to the effective collision, and then the last one, rate of reaction, still the same. Okay, here there's some mistake. Suppose it's concentration of reactant. So reactant, so when concentration of solution increase, the number of reactant particles per unit volume increase. So again, 0.2, 0.3, 0.4 is the same. Okay, the last one you can mention about catalyst. Catalyst, you have to write down the function of it. Provide an alternative pathway. How? With a lower activation energy. So then, more number of reacting molecule with energy equal to or greater than the lower activation energy. So frequency of effective collision increase. And the last one is the rate of reaction increase. I hope you all not sleepy. Let's continue for the third question, PSPM2 set 2017 and 2018. So again, this is the original question. Okay, question I already analyzed and highlighted. So let's go through the question together. Okay, N2O5 decompose to NO2 and O2 according to the following chemical equation. So again, table 1 show the change of in N2O5 concentration again time when the reaction is performed at 50 degrees Celsius. So this reaction happened at 50 degrees Celsius. So determine the order and the rate constant for the reaction using a linear graph method. So no choice, you have to do the linear graph. And then based on the previous information, there is no hints for the order of the reaction. So okay, never mind, we continue first. From the graph, what is the half-life? So you have to determine the half-life based on the graph. Okay, given EA of the reaction is 58 kilojoule per mole. During class, I already told you all right. If the EA given in kilojoule, you must times 10 to the power of 3 or times 1000, commonly become joule per mole. Okay, calculate the rate constant at 65 degrees Celsius. The T1 is 50 degrees Celsius. And then the T2 is 65 degrees Celsius. So now the question asks you to find the activation energy. No. Calculate the rate constant. Okay, calculate the rate constant since the activation energy is given. So this question is obvious. You need to apply Arrhenius equation. Okay, next, compare the rate constant, the K, at the two temperature. So one is 50, another one is 65. And explain it when it in terms of collision theory. If collision theory means you have to mention about the what happened to the frequency collision, and then what happened to the effective collision, and then what happened to the rate of reaction. Okay. Last, describe how the addition of catalysts affect the rate of reaction. This is exactly same as last question, but last question in general, but this question in specific want to explain in terms of catalyst. For the plotting of the graph, this time no choice. You have to try to plot three graphs. Okay, so before you plot three graphs, plotting the three graphs, you have to prepare the data for concentration versus time, long concentration versus time first order, and then 1/over concentration versus time second order. You have to prepare all the graph and table. Then you check which obey the graph pattern. If you get a negative slope for concentration A versus time, then it's zero order. You get a negative linear graph, then this one is long concentration versus time, and then this is first order. And the last one, if you get a positive slope with linear graph, then this is second order. So as we discussed before, for this question we need to prepare three tables, plot three graphs. So here is the final answer. Okay, for the linear graph method, so the marks will be given if you show the data for long concentration N2O5. Okay, so this table I think roughly 1 mark. Then again you have to plot the graph. As I said before, there are 5 points. First, the title of the graph. Second is the y-axis for long concentration N2O5. And the x-axis is over here, time per minute. And then the third point is about the skill. And then fourth point, you have to assign the dot according the long concentration N2O5. And then lastly, you have to connect all the points. After that, okay, let's answer the next question. So graph on lone N2O5 against time is a straight line with negative slope, proven that this is a first order reaction. So meaning that when you plot for the zero order and second order graph, you wouldn't get the pattern of the graph. Only lone concentration N2O5 you get the negative slope and linear graph. Okay, now the question asks you to find the gradient based on the graph. Again, by using the method I said before, you need to find out 2 points, x1, y1, and x2, y2, and then you find the y2 minus y1 over x2 minus x1. Then you can find the gradient, which is 0.271 per minute. So next question will ask you to find the half-line of this fraction. So I think most of you will try the yellow box. You try to answer by using the yellow box methods. I tell you, cannot. This yellow box just for checking purpose only. Why? Because the graph already mentioned, the question already mentioned we need to find out the half-life from the graph. So how? First of all, you must understand, given over here, okay, the initial concentration of N2O5 is 1.00. So the half-life means the concentration will be reduced to half, which is 0.5. Okay, so the concentration is 0.5. And then you try to convert the 0.5 become ln 0.5. Then the answer is negative 0.693. Once you successfully get the answer for the negative 0.693, okay, then you can find out where is the negative 0.693. Okay, here is the negative 0.693. So you extrapolate it, you'll notice, right, at negative 0.693, so the time is 2.56 minutes. Okay, if you're scared, you are able to plot an accurate graph, never mind. There is another method. You can check the half-life first, and you try to adjust and then try to modify your graph. Actually, not modify, maybe just now the graph that you plot is not accurate, so try to repair it. Okay, and then you notice the half-life is 2.56. Okay, the next is about Arrhenius. I think Arrhenius is quite simple. Just be careful. Okay, always write out the formula, substitution, and then the final answer with unit. Okay, so this is the K1. Okay, the question asks you to find the K2. Okay, please make sure you know how to press the calculator in order to find out the K2. Okay, if you're not there, never mind, you just do it part by part. Maybe you can settle this part first, then only this part, and then you shift ln for the answer. Then okay, and then 0.271 over the answer that you get from here. So the K2 is 0.707 per minute. Normally you all no problem to write down the formula and then substitution, but the problem is when you press the calculator, so must be extra careful when you press the calculator. Okay, next, compare the rate constant at the two temperature and explain it in terms of the collision. The question asks you to compare, right? Compare larger, smaller. So at higher temperature, what happened? Rate constant is larger. Okay. Next, at higher temperature, what happened? Okay, this one is familiar with you all. So move faster, frequency of collision increase. So number of molecule with energy greater or equal to activation energy increase. Number of effective collision increase. And the last one, what happened? The rate of reaction increase. Okay, hence the rate constant increase. Okay, because rate is equal to K concentration to something. So if K increase means if rate increase, the K also increase. I'm referring to the rate equation. Okay, last simple question. So what is the function of catalyst? How catalyst affect the rate of reaction? Increase catalysts increase the rate of reaction by providing an alternative pathway that require lower activation energy. Okay, yes, final set, PSPM2 set 2018 and 2019. So this question, okay, this is follow the latest format. So question 1, 14%. Okay, so it's much more easier compared to previous one. Okay, so the reaction is first order, given is first order, and they ask you to determine the rate of formation of O2. Okay, this is easy question. And then calculate the rate constant. Okay, 25% is decomposed, so remaining is 75%. Okay, because when we deal with the integrated rate law, right, we have to find out the T at the T after some time is the remaining concentration. Okay, within 10 minutes. 10 minutes. Okay, so A3 determine the half-life, so you must know what is the formula for half-life in first order. So this one you must memorize the formula. So what is the formula? What is the formula for first order half-life? Go to recall. Okay, so the answer is ln 2 over K. Okay, B. Table 1 show the rate constant for the decomposition of N2O2. Okay, C1, T2, K1, K2. Okay, simple question because it is applied Arrhenius equation. But be careful because this time the final answer must in kilojoule per mole. What you find is in joule per mole first, then you need to convert to kilojoule per mole. So divide by 1000. So B2 activation energy can also be determined graphically. Okay, sketch. The question just one, sketch. And explain. So, okay, I think should be no problem for you to write down this rate equation. Okay, the question formation. Okay, formation, so this is positive, product is positive, reactant is in negative. So this is the rate equation. And then the rate disappearance is given, or rate disappearance of this one is given. Okay, and then, okay, write down the rate equation, substitute, and then you get the answer, and then make the conclusion. Don't forget to make the conclusion. Rate of formation of oxygen is, and then don't forget the unit, molar per minute. Okay, for question A3, okay, this one simple. As I said before, you must make sure that you must finding the remaining concentration, which is 0.75 molar. Okay, and then write down the equation, formula, and then substitute the value. Then find out the value of K with unit, which is per minute. 3 is apply formula, ln 2 over K. So make sure the K that from B2 must correct. If not, right, your B3 will get wrong as well. So the answer is 24.15 minute. Final unit again. Okay, B, Arrhenius equation, formula, substitution, and then the final answer, convert to kilojoule per mole. Make sure. Okay, EA that you find first is in joule per mole. And then make sure temperature must convert to Kelvin. Then apply the calculation and then convert the answer in kilojoule. Okay, activation energy, this is the graph. So y-axis ln K, x-axis is 1 over T, and then give a negative slope, and then at the C point is ln A. So this is the initial equation for the Arrhenius equation. So you must know how to derive it. Become negative EA over R. So the negative EA over R actually is referred to here. This is the negative slope. That's why the EA after negative will become positive. That's all for chapter 1 revision. Thank you very much. Hope you all can try more exercise to enhance your skill to answer the PSPM question. Bye.